Welcome. Let us now discuss a problem in variable acceleration. Okay, getting into the problem. A particle's movement is given in terms of equation as follows. Now an equation is given, that is equation which defines distance in terms of time like this. From the mathematics perspective, any phenomena or any process can be defined in terms of equation. Similarly, here a movement is defined in terms of equation. Now, there are three different questions here which are based on velocity, acceleration and distance. But we have only one information which is all about distance. We need information about velocity and acceleration. So, right now what we have to do means we have to derive one equation for velocity and another one for acceleration from this equation, that is from the equation of distance. Let's do that first, and after that let's move to the problem or solution. Okay, we have this equation from the question, and velocity can be defined as change in distance to the change in time, which also defines its unit, meter per second. Okay, and introducing this s term here, we get this form of equation. Now what we have to do means we have to differentiate this equation with respect to time. Let's have a sample differentiation here. If we differentiate x to the power n, means this n will come to the front and the x to the power will be reduced by 1. If you differentiate x to the power 9, means n will come to the front and its power will be reduced by 1, which is 9 into x to the power 8. Let us differentiate similarly here also, and by differentiating we get the equation for velocity. Similarly, we have to derive an equation for acceleration. Acceleration can be defined like this: change in velocity to the change in time. We know velocity from this derivation part, and introducing this velocity here we can find the equation for acceleration. Now we have found three equations, one for distance which is given in the question, and velocity and acceleration. And let's now move on to the question. The first question is all about at start and after 5 seconds of time, what will be the particle's velocity. At start means when the time is 0, that's what it means. That is the first question. And another one question in the first one is after 5 seconds of time. Okay, so first we have to find out what is at t equal to 0, and second one, what will be the velocity when time equal to 5 seconds. I am writing all those three equations here and getting the velocity equation. Since the velocity is a question, I am utilizing the equation which is meant for velocity and introducing 0 in terms of, that is in places of t, we get this equation, and calculating we get velocity is 2 meters per second. And second one is we have to calculate the velocity when the time is at 5 seconds, and utilizing the same equation and substituting 5 in places of t, we get this equation, and finally we get velocity as 727 meters per second. Okay, with this let's move on to the next problem. At start and after 5 seconds of time, what will be the particle's velocity? At start means at the beginning, that is when time is equal to 0, and when time equal to 5, what will be the acceleration? Now utilizing the equation which is meant for acceleration, introducing that equation and substituting 0 in places of time t, we get acceleration. Similarly, we need to find the answer for the second part also when time is equal to 5 seconds. Utilizing the same acceleration equation and introducing 5 in places of t, we get this equation and answer like this. Let's move on to the final question. From the time 3rd second to the 5th second, what will be the distance covered by the particle? Okay, let's now first calculate what is the distance covered by the particle when the time is 3 seconds, and what will be the distance covered by the particle when the time is 5 seconds. Okay, that's all about this. Since the question is all about distance, let us now utilize the equation which is meant for distance. Okay, now introducing this equation, distance equation here, and substituting 3 in places of time, we get this equation. Similarly, introducing 5 in places of t, we get this equation like this. Proceeding with the solution part, we get when time is 3 seconds, the distance moved by the particle is 294 meter, and when the time is 5 seconds, the distance traveled by the particle is 1260 meters. But the actual question is all about what will be the distance covered by the particle in between, that's when time equal to 3 and when time equal to 5. So subtracting 294 from 1260, we get the answer. So I'm subtracting here and finding out the answer. Okay. With this we come to the end of this video, and thank you.